All right, I'm going to talk about special right triangles. So we got two right triangles here. These are special because of the ratios that you're going to see. The first special right triangle is sometimes called a 45-45-90 triangle, and the other one's called sometimes a 30-60-90 triangle. And I'll start with kind of showing you the setup here, and then we'll do a couple examples. So 45-45-90 has a very particular pattern in that the side lengths, which I'll just call x, keep it generic for now, the sides, the legs of this triangle have to be and will always be the same value. I use x, but this could be anything. I mean, if this is y, this has to be y. If this is xy, this has to be xy. If this is if this is happy face, this has to be happy face. The point being, whatever is there, I'm losing my triangle. Whatever is there has to be the same on both sides. So x is just the variable we use the most in math. And the hypotenuse, remember the hypotenuse is the side that's opposite of the right angle. It's also the longest side of the triangle. It's always going to be your side length, your leg length, times radical 2. And so, with this in mind, if I just jump into a very quick example, if you're given that you have a 45 degree angle, and you're given a side length, if the side length is 3, instantly you want to know that the other side has to be 3, and the hypotenuse is the side length times rad 2. And that's it. If this was 11 halves, just throw some number on there, this would have to be 11 halves. And this would have to be, oh my goodness, this would have to be 11 halves, the side length, times radical 2. I'm just kind of filling in the structure of this. And so notice that, yes, I used x up here, but when you solve the problem, these three numbers, whatever you call them, those three numbers have to be the same. If I do one other example that was throwing a few people off in my class, let's say you're given a 45-45 triangle, and you're given the hypotenuse. And let's say your hypotenuse actually happens to be a nice number. We'll use 5. And then you're asked to find, the missing side lengths. Sometimes they use different variables to throw you off. But remember, in this case, x and y have to be equal. Because by definition, going back up here, the legs have to be the same variable. And so, even though this is y here, you can think of it as the same thing. It's going to be some x. So here's the trick. The hypotenuse right here has to be your side length times radical 2. It just happens to be a nice number. And so, you have to set up an equation saying, well, I was given the hypotenuse, but I was told by Mr. Smith, and I trust Mr. Smith, that it has to be side length times rad 2. And so the substep of this problem is setting your formula, right, side times rad 2 equal to 5, and solving for your side, solving for x. When I divide, the rads cancel, and I've got that 5 over rad 2 is x. And remember, x is my side. And that's the answer, 5 over rad 2. Now, it's tradition. The mathematicians years ago decided that you don't want a radical on the bottom. I believe they decided that because a radical is irrational. It's a decimal that goes on forever, and you have a really hard time dividing something by something that goes on forever. And so to clear that up, you can do something called rationalize the denominator. And if you multiply by 1, but you're picking a clever form of 1, you're picking the radical over the radical, then what you have is 5 radical 2 over rad 4, which is 5 radical 2 square root of 4 is 2. And so even though I said x is 5 over rad 2, which is correct, many teachers, professors might ding you a point for not simplifying. This is absolutely equivalent to 5 rad 2 over 2. And the good news is if I found this side, excuse me, I can't speak, then I also found this side. This is 5 rad 2 over 2. And that'd be it. So, applying the same principles to my 30, 60, 90, it's similar logic, but the ratio is different. If you have the short side here, and this isn't drawn to scale, so you have to pay attention to your triangles, the hypotenuse is always going to be double that side, and the long leg, the longer leg, is going to be your side length times radical 3. And again, the reason this is the longer leg is there's a bigger angle here. You got a 60-degree angle versus a 30-degree, and so a better picture might be, slightly skinnier angle up here. Anyway, just go with it. So, if you have the side, you can double the side to get this, and you can take the side and times it by rad 3, and it gets a little tricky because sometimes they'll give you this side to start and you find the other two. Sometimes they'll give you this side to start, and you just have to kind of be comfortable going in multiple directions. And so let's turn this let's turn it on its side a little bit just to kind of throw a curveball at you slightly. We'll put the 60 degrees up here, 30 degrees here, and then maybe we'll put 14 here. And we want to find the missing two sides. And so don't even worry about the fact that they're not labeled. I just want you to see that I have the hypotenuse. I have the longest side, the side between the 60 and the 30. And so this corresponds to 2x. So if you think about this as 2x, and you do mental math, solve for x, you might say, okay, x is 7. You could do that, or you could just say, well, this has to be half of this. So half of 14 is 7. Just cut it in half. If this is 7, this is 14, If this was 18, this would have to be 9. If this was 100, this would have to be 50. This pattern is always going to hold true. I'll go back to 14 because 14 doesn't get used enough, so I'll throw 14 on there, and that means this is 7. And then this long leg, this other side between the 90 and the 30, 90 and the 30, this says that it's my short side, which is 7, times rad 3. And that's how you fill in the missing pieces. We'll do one last one at a super ultra fast speed. Just to throw a little wrinkle in it. Let's just say that we have a rad 3 down here. This is the short side. So this is supposed to be 2 times rad 3. I doubled it. And this is supposed to be rad 3 times rad 3. Again, this is x. All right, this is 2 times x. And then the only thing I can simplify here is if I do have a rad 3 times a rad 3, it's a rad 9. And the simplified version would be that this entire side here, you can rewind the video if you need, would end up being just a 3. So, thanks for watching. Have a good night.